Alright, what I'm going to do is go through a couple of these problems on the work packet from Unit 8. A few of you said you wanted to see some examples of the problems, so I'll go through a couple of those. So I'm going to be looking at the work packet for Unit 8, which is Energy and States of Matter, and I'm looking at page 9. And that's going to start with number 6. Alright, so the whole idea behind these problems is that we're taking a piece of metal, usually at a higher temperature, and we're placing it in water. And what's going to happen is the heat is going to transfer from the hotter metal to the colder water. So we can use that idea to solve for various variables in these equations. Alright, so the way I would usually do this is I would set up Q is equal to MC delta T, which is T final minus T initial for the metal, and I'm going to set up Q is equal to MC delta T for the water. A couple things you want to notice about these equations. Again, since all of the heat is being transferred between these two things, your values for Q are going to be the same. Now the thing that's going to cool down is always going to have a negative value for Q. In thermodynamics, when something is exothermic, in other words it's losing energy and cooling down, we give the sign for heat a negative value. So whatever we have for this Q, we can have for that Q. It's just the one that's cooling down we say is negative. So for example, let's say we're able to calculate Q for water and we get a value of 10. We would put Q for the metal as 10. We would just make it negative 10. The other thing you want to remember with these problems is that your final temperatures are always going to be the same. Because again, we're waiting for the metal to cool down and the water to heat up until they come to the same temperature, so your final temperatures are always going to be the same. So then what I would do is I would go through the problem and I would put the values where they fit in our equations here. So remember, Q stands for heat or energy, M stands for mass, C stands for specific heat, final temperature, and initial temperature. So when you read this first problem, it says a 75-gram sample of metal. So over here with the metal, I'm going to put its mass as 75 grams. The metal is at 98 degrees Celsius, so before we do anything, we know its initial temperature is 98 degrees Celsius. It's dropped into a container of water that contains 350 grams of water. So over here, we know the mass is going to be 350 grams. And that water is at 24 degrees Celsius. So before anything happens, we know that the temperature of water is 24 degrees. It says the final temperature is 24.5 degrees, so I can put that there, and I'm going to try to squeeze that in there. Let me fix that because it looks like a 29. So let me put 20, come on, 4.5. Okay. Now C for water we know is always a constant, and that constant is 4.18, and I tried to squeeze that in there. Okay, so that value for C is always 4.18. So what you can see now is we have all of our variables M, C, TF, and TI for water, so we can calculate Q for water. So let's do that. I'm going to put in my calculator 350 times 4.18 times the quantity 24.5 minus 24, and I get 731.5, and again the unit for Q is joules. Alright, so now I can take that 731.5 and I can plug it in for the Q for metal. So I'm going to put 731.5, but I'm going to make it negative. So I'm going to put a negative sign there. I'm solving for C and my final temperature. Again, remember the final temperatures are the same, so I know that value also. Alright, so now I just need to solve for C for the metal. And once I do that, I can look up the value for C on a chart and match it and identify what the metal is. So let's do that subtraction first. So 24.5 minus 98 is going to give us negative 73.5. Now you want to make sure you pay attention to these signs because we have negative 731.5 and negative 73.5. So those negatives are eventually going to cancel each other out. So now I just need to solve for C here. So to isolate C, I'm going to divide both sides by 75 and negative 73.5. So 75 times negative 73.5, put that negative there. So those cancel. So all I have left on this side is C, and then I just need to do the math over here. So I've got negative 731.5 divided by 75 times negative 73.5, and I get a value of 0.13 for C. And that's a pretty reasonable value for C. Most of the time you'll find that they end up around between like 0.1 and 5 or something. Alright, so let's take a look at the next one. Again, I've got my metal, so before I even write the problem, I'm going to set it up this way. And I've got Q is equal to MC TF minus TI. Q is equal to MC TF minus TI. So now I go through the problem and put in what I can put in. I've got a 55 gram sample of metal. So again, over here I've got 55 grams. It's 90 degrees Celsius before anything happens, so its temperature, whoops, let me get rid of that. So its initial temperature is 90 degrees. It's dropped into a container that contains 250 grams of water. So that's my mass of water at 22 degrees Celsius. Now remember, the C value for water is always 4.18. The initial temperature of the water is 22, and the final temperature of the water is 23.4. That's supposed to say 23.4. Alright, so again, I can solve for Q here, and when I do that, 250 times 4.18 times the quantity, 23.4 minus 22, I get 1,463 joules. So again, I'm going to put that over here for my Q, but I'm going to make it negative, 1,463. I'm solving for C. My final temperature is the same, so I'm putting 23.4. And I'm going to solve for C here. So 1463 divided by 55 divided by the quantity, 23.4 minus 90. I'm going to get 0.399. So you can go through and do that math and figure that out. But then that's your value for C there. Alright. So if you look at the next one, you're going to see it's the same basic type of problem. Mass of your metal, initial temperature, dropped into a certain mass of water at a certain temperature, and you've got your final temperature. So you can go through and again do that with the metal, the water. Q is equal to MC T final minus T initial for both of them, and you can do that. Don't worry right now about the percent error. We'll talk about that in class. We've done that with a number of labs, so we'll talk about that later. I just want to set up the last one for you though, so you have an idea how to do this. Alright, so again, let's just say you're reading through this and you start setting it up the same way, And let's say you have Q is equal to mCTF minus TI. Q is equal to mCTF minus TI. So you're doing the same thing. So what you're going to notice with this one is going to be a little bit different. So we've got our 45.2 grams. Now we know that it's silver, so what we can do is look up the value for C for silver. Now in a normal problem this would be given, and what you're going to notice if you look on your chart that the value for C is 0.24. Oh, let me rewrite that so there's no mistake. So you've got 0.24 at 101 degrees Celsius, so I'm going to put that there. And it's dropped into 300 grams of water, so I'm going to put my 300 grams here. And remember, water is 4.18. Let me fix that 4, sorry. Again, I don't want any misunderstanding here. This thing is not the easiest thing to write on. Alright. And you're the water is at 30.6 degrees Celsius. So now it says, what is the final temperature? So we're solving for the final temperature. And remember, the final temperatures are the same, so these TFs are going to be, whoops. Let me rewrite that. Sorry, I'm trying to rush here and I'm making a mess of this. So these TFs right here and right here are the same value. It would be like having X and X. So we're going to solve for that. The question becomes, how do we solve for Q when we don't know the final temperature and we don't know Q? So we have two unknowns. So since these Q values are equal, and Q is equal to that whole quantity, what we can say is that mc delta T is equal to mc delta T. You just have to remember to make the metal side negative. If you don't really understand why we can do that, it's really not a big deal. You just have to trust me that you want to set these two equations equal to each other, put the negative sign in front of the metal, and now solve for TF. And I would like you to do that math on your own. We'll go over it in class, but I want to see if you can do that, and plus I don't want to make this podcast that long. So solve for TF here and see what you get. And you know that your metal is higher temperature than the water, so you know your TF value should be greater than 30.6, and that'll be one indication whether or not you're doing it right or not. So anyway, hopefully that this podcast will help with doing some of these problems. It's very important that you understand how to do this. So what I would do is do the problems, make sure you go back and check your answers, and if you need to, just rewatch the vodcast. And again, as usual, don't hesitate to ask questions in class, or you can ask questions on thannanen at ldsd.org. So again, in case you have forgotten how to spell that name, thannanen at ldsd.org. Alright, great. See ya.